This video has been supported by Bluetti. Hey folks, I'm making good progress with my solar system, but of course that industry is plagued by the same supply chain troubles as everybody else. So while waiting for the last few components for a fixed installation, I'm going to give Bluetti's AC200MAX a try. An absolutely enormous, more or less mobile battery power station. This big box full of delicious lithium iron phosphate and this optional extension battery pack have been provided by the manufacturer for this independent review. Fundamentally, this is the same thing that I intend to use to turn my DC solar power into something that all the average AC enjoyers in my house can consume. A 50 volt battery, a maximum power point tracking charger for it, and a powerful mains output inverter. Today I want to find out if it is well made, thought through, and able to power my whole lab. It should, and for a good long while. I get the impression that this product is not really meant to be carried around as much as the smaller power stations that we've tried before, just because of how huge and heavy it is. You could of course strap it to one of these vintage Tektronix lab carts and have a boat anchor powered by a boat anchor. But I think it's mainly interesting for powering remote cabins in the woods and RVs, the value proposition being that you are getting a functional, hopefully safe, plug-and-play solar generator for the installation of which you hardly need any electrical knowledge. The hardest part in the installation might just be plugging in this appropriately chunky cable. To connect an extension pack with the main unit, up to 2 can be connected. That is a really tight fit, holy moly, not sure if that's ever going to come out again. In most high energy scenarios, hot plugging is a cardinal sin, and it will get you fired in more ways than one. In this case, the manual doesn't seem to be strongly opposed to it. In fact, occasionally I have heard relays clicking inside of the units, so it might just be safe either way. One thing that I didn't understand right away, closely related to the hot pluggability, is that this locking switch, in addition to mechanically blocking the connector release button, also needs to be engaged for the devices to recognize and communicate with each other. The cooperation of multiple modules in various functional or non-functional states is a great source of quirks in this system. We'll meet a few edge cases in a moment. But first, feeding time. This toiletry bag holds all of the accessories that came with the kit. There is a huge wall charger and a DC input cable. Initially I had a small concern about the mains charger's TÜV certificate not being verifiable online. A representative was able to show me the detailed few hundred pages TÜV test report for that part though. The Fuyuang brand is also a fairly big deal with a German distributor and all that, so I am appeased. The AC200MAX itself doesn't claim to have any such certificates on the box, but searching for the manufacturer, Power Oak, behind the Bluetti brand, reveals that, hey, it has a valid TÜV certificate. Very nice. I'm not quite sure what that means exactly, so I'm still going to have to take it apart in a moment and judge for myself. For the DC input cable you're getting a cigarette lighter and an MC4 style solar adapter. It's unlikely that I'll ever use it, but I like what the cigarette lighter adapter implies. If there is a 50 volt battery pack in here, then how are we going to charge it with a 12 or 24 volt cigarette lighter input? For that to work out, there must be a voltage booster circuit, and that would be very cool. Let's give that a try with this anonymous competitor battery product. Oh, you bet it works. We are currently charging this whole thing from the ubiquitous 12 volt input. Very useful. Now, does that mode also have MPPT capabilities? I think it does. Only at the very low end of the allowed input voltage range is it slow like this. It could draw up to 120 watt from this port, but it only takes 60. Here is one 30 volt, 230 watt peak solar panel. And that is without a doubt MPPTing. Also known as drawing as much current as possible before the panel voltage breaks down, depending on clouds and burp shadows and whatnot. To max out the PV input capability, we need a string of 4 of those panels. Here we are primarily limited by an open circuit voltage of 145 volt max that the power station can take. So for example 5 30 volt panels in series would be too much. That would give us an input over voltage alarm, and if we went much further than that, we might even damage the charge circuitry. Yeah, reaching the 900 watt max PV input does require a bit of skill, and handling of potentially dangerous voltages. I'll talk some more about series parallel panel configurations in my next solar video. Overall, I would say the AC200MAX is very forgiving and it can utilize just about any DC source you can find out in the wild. Only getting to the very high input watt numbers is tricky. Their smartphone app situation is alright, I think. They don't force you to create an unnecessary account, because the AC200MAX doesn't have any online capabilities on its own anyway. It only has Bluetooth, and with that the app gives you access to most of the functions that are available on the display. Useful for when you want to hide away the generator somewhere in a fixed installation. But did you notice something? There is no access control whatsoever. Everybody with this app can control every AC200MAX within range. A very malicious actor might even be able to upload a modified firmware to the thing, with incorrect BMS settings maybe. You get the idea. The range is limited and the risk is low, so I very much prefer this over a vulnerable IoT device. But I think the Bluetooth in my device will remain off until a future firmware version adds a pair prompt on the LCD. The main unit has 2 fast wireless charger spots on top, and plenty of high-power USB outlets on the front, including one 100-watt USB-C power delivery outlet for charging laptops and powering USB soldering irons. There is also a chunky 12-volt 30-ampere circular connector on the left, ideal for connecting this thing to a low-voltage onboard power grid of RVs and boats, in a more rigid manner than the wobbly cigarette lighter. The extension battery pack has a minimalist user interface, but in some special situations it can also be a standalone unit with some useful outputs of its own. What I'm kind of missing on both of these units is a more direct access to the internal 50-volt battery voltage. Under BMS supervision of course, but with no power conversion in between. With that, one could more easily integrate these boxes into a larger off-grid solar system and connect a huge inverter to them, like the one you can see here in the background. The continuous 2200 watt pure sine inverter that is integrated into the AC200MAX is nothing to scoff at. With smaller mobile power stations, the sales pitch is usually, wow, look, you can power everything outdoors. And only in the fine print is it mentioned that it's too weak for anything that heats or cools, like hot plates, coffee machines, AC units or mini fridges. Well, this beast really can satisfy all of those consumers. I don't own a household appliance that needs more than 2200 watt. No, I really don't have a full-size oven. The spot where one used to be is now occupied with electronic components. It takes about 100 watt-hours of energy to boil a liter of water. That's about 5% of the capacity of the AC200MAX alone, or 2.5% of the combination with one extension battery. That means that initially I could boil 40 liters of water with this set. Or with an average of 600 watt solar input at daytime, I could boil a fresh liter of water every 10 minutes while maintaining a fully charged battery. Personally, I'm not that big of a coffee drinker, so here's a nerd-compatible Wolfram Alpha comparison. The energy stored in this system is approximately equal to minus 30 times the enthalpy change when 2 moles of gaseous hydrogen combine with 1 mole of gaseous oxygen to form 2 moles of water vapor. Or, for the other end of the spectrum, it's a huge battery capacity. So let's see how it powers my living lab. There doesn't seem to be a ground neutral bar in this unit, and there doesn't seem to be a residual current circuit breaker. I think the grounds are just not connected to anything internally. So if, theoretically we were to flip the circuit breaker for my lab, that would disconnect the live phase, and nothing would keep us from feeding power into an outlet, technically. Of course, for this demonstration I've done something a lot cleaner and completely electrically up to code. So let's see if we can survive an average, slightly overcast summer day, just on 4 solar panels and 1 Bluetti AC200MAX worth of power. All day long I would like to power 4 voltage standards, one of them with a Siglent bench PSU. And 2 3458As and a Raspberry Pi for long-term data logging. That and a few standby consumers is my normal baseload. About 100 watt of mostly unnecessary standby stuff feels like a lot when we are counting pennies. But I think the biggest consumer throughout the day is going to be my PC. It's a somewhat gameable machine with an RTX 2080 and a Core i9. I never actually measured its power intake, but since I built it in 2019, I hope that it's somewhat energy efficient and not too hungry when not under load. Half of my day is reading emails and Discord meme channels after all. That's the bare necessities. Looks sustainable so far. And we've got plenty of headroom for breakfast. Oh yeah, that water kettle is bringing us close to the power limit now. We could certainly not vacuum the floor or charge an e-bike at the same time. But I'm not in the habit of doing that anyway, so it's all good. I seem to have picked the worst day possible for this experiment. We had a near painful amount of sun in the past few days, but today the forecast remains mostly cloudy. Oh well, that's reality on solar power, and therefore a part of the experiment. Yep, uncultured swine that I am, I'm totally eating at my desk. Hey, at least it's not the test gear bench, this time. I feel like at around 130 watt while editing this video, my computer's power intake is quite reasonable. But with the cloud situation, our Bluetti state of charge still has a slow downward tendency on average. While we cannot add more solar panels to our series string because of the VOC limit, we could certainly have multiple strings in parallel to catch more power. The inverter cooling fan is pretty loud and I don't like working in the same room with it. I noticed it spinning up occasionally even at a 0 watt AC load with the inverter just being on, so definitely it belongs in a separate room. Here's a relatable noise comparison for you. Okay, it's 1 PM and we are doing good so far. But now my walkies and lunch break alarm is ringing. We'll be gone for about an hour, so I'll try something completely unprecedented here. Turning off my PC in the middle of the day. By now there is some serious sun outside, so this way I hope we can recover some of the charge we lost earlier today. Dexter doesn't care that much about sun or no sun. As long as it's over 23 Celsius, it's swimming weather. Yeah, good, we got a few percent of charge back over the last hour. And my apartment is not on fire, that's also a pleasant surprise every time I come home. Let's make another big dent into the charge, with lunch. White rice cooking time can be accelerated significantly by soaking it in water a few hours before consumption. Don't worry, uncultured or not, this is not my preferred cooking location. I'm just here because this is the only room that is solar powered for now. For some flavor I'm adding a proprietary spicy beanie chili, which is prepped once per week and lasts multiple days. Maybe if I ever run out of electronics topics I'll share the secret recipe. Cheers! Okay, that's a few more hours of normal desk work done, and now I'm certain that we'll make it through the day no problem. That is, as a single household with low standards and the kindness of the sun. In winter it'll be much harder, but for that I have 10 times as many solar panels as I'm using now. Let's put the boring desk work aside and push this thing to its limit, at the other desk. It's great to see that the big JBC station really does have such a low standby power consumption when all tools are in their cradles. The hot air station is rated 1.2 kilowatt. The soldering fume extractor will also draw some power. And if all else fails, we have a brutal air compressor which should also play in the kilowatt league. Oh look, all of this is child's play in comparison to cooking a cup of tea. And the hot air station is only really power hungry in the first few seconds after waking up. No, none of this is anywhere near a challenge for the Bluetti. Time to bring out the biggest gun in the arsenal. Oh, hello. Wow, well that thing sure is a big consumer. The air compressor alone helps itself to around 2.2 kilowatt. And so single-handedly pushes us over the power station's nominal output power. It seems to have survived it without hiccup though, so we've got to get more creative. How about compression, heat and suction for the desoldering tool, and hot air at the same time? This is how I imagine working at McDonald's feels like. Oh, I think I can hear it beginning to struggle. But it seems to be churning out almost 3 kilowatt now, which is very impressive. The voltage standards, a lab bench power supply, 2 large multimeters and a computer are also still running in the background. Yeah, this is fantastic. This thing can reliably power an uncompromising electronics lab and some power tools on top. But now, time for the coup de grace. I'm going to power up everything, everywhere, all at once. Now including the fume extraction. There we go, victory at last. Seems like 3000 watt is the limit where it taps out. This triggers a serious alarm in the AC200MAX that has to be cleared manually before the AC output can be enabled again. That's a good safety precaution, I think. But there is this one inconvenience I'd like to point out. If you do manage to run the battery completely flat somehow, then the AC output is turned off and it remains off even after recharging. If it isn't recharged soon, or if somebody presses the power button on the main unit, then the main unit itself and the expansion battery pack are shutting down. If a PV power source is connected, the main unit wakes up the next morning at sunrise, but not the expansion battery pack. Somebody has to physically go there and press the button for it. It's a minor inconvenience, I guess, but it would have been super nice if the units remembered their states and returned to them completely without human intervention. Okay, teardown time. The manufacturer wants me to add the following disclaimer, and to be honest, I agree with them in this case. It's not only dangerous to open these units, but it's also unnecessary, because you're getting a 2-year warranty with these premium products, which expires when you open them yourself. So don't risk a battery fire or electrocution from the charged high voltage capacitors in here. If there ever is a problem with your Bluetti, let the manufacturer take care of it for you. And better let me take the risk of poking around in here instead of doing it yourself. First victim, the B230 expansion module. Wow, this is a lot more complicated than I would have thought. Remember the 100 ampere lithium iron phosphate battery we've taken apart recently? This is its BMS. I don't think the Bluetti is rated for 100 ampere, yet it's so much bigger. Let me try to make sense of it all. This small front panel board is most likely responsible for the USB outputs. Meanwhile, the 12-volt 10 ampere cigarette lighter output is connected all the way to the rear to another pretty dense board. Let's call it a DC to DC module. The battery protection section is so much larger than that of the other BMS because it has a lot more functions. The main battery negative terminal is connected through parallel fuses and current shunts to 2 back-to-back MOSFET switches consisting of multiple parallel MOSFETs each to keep their on resistance low. This allows a controller to selectively disable charge or discharge or both when things are getting really hopeless. In my opinion, the single most striking component on this whole assembly is a gigantic 50 ohm 20 watt wire wound power resistor. My first thought was that could be a dummy load for a self-test and calibration feature. But no reps, not everybody is so obsessed with accuracy. Instead, I think it's a pre-charge resistor that bypasses the low resistance discharge switch. Using it, the controller can gently pre-charge the input capacitance of the inverter, or whatever else is connected, instead of clonking on the low resistance switch, which would allow excessive inrush overcurrents to flow briefly. You know me, I'm not a strict safety fanatic, but I think some basic respect for 20 kilograms of lithium iron phosphate batteries is healthy. Especially since without this board they probably have no further protection. So for further disassembly I'm briefly heat shrinking the battery terminals so that absolutely nothing can short them out. Overall beautiful construction in here. Conformal coating and anti-vibration silicone everywhere. Mostly brand name components and silicone isolation and textile sleeves for all the high current cables. And here's the battery pack itself, made from 26700 lithium iron phosphate cells. That's not the number of cells, but their size-based name, like 18650. Here's what I called the DC to DC module a moment ago. I didn't expect to find forced air cooling in here, but it makes sense. This small board is a 500 watt charge controller and a 50 to 12 volt 10 ampere buck converter. I don't think this one can boost lower input voltages to charge its 50 volt pack, and it also doesn't have an MPPT tracker of its own. Bluetti sells optional power bricks to add these functions to the expansion packs. I don't think I need one. I'm okay with the 900 watt solar input of the AC200MAX, which it partially passes on to this B230. Yeah, pretty impressive overall. At the moment this product alone is more than $1,000. That isn't the best watt-hour per dollar ratio on the lithium iron phosphate market, not by a long shot. But seeing all the effort that went into it, and considering that some customers just want the convenience of a plug-and-play solution, I think it's fair. Okay, next the intimidatingly big guy. Don't do this, by the way. The enclosure is obviously not made from metal, but I think there are solid aluminium bars going through the handles. And these enormously long screws are connecting those all the way to the bottom of the unit. Unsurprisingly, it's even busier in here. In addition to likely the same battery and battery management solution that we've just met in the extension pack, this one features a 900 watt MPPT tracker and a 2200 watt mains inverter, until one fateful day a curious reps came along and stole it all. What remains in the unit is an off-the-shelf, third-party touch LCD module with an SD card slot that just isn't used in this application, and the same multi-protocol USB output module that we've seen in the extension pack. This tiny board seems to be the one and only brains of the operation. It features a local bipolar power supply for all the single and quad op amps on its right. Judging by where the top ribbon cable goes, I would guess that these op amps are mostly signal conditioning for feedback from the mains output inverter. The inverter no doubt is controlled by this Texas Instruments TMS320 digital signal processor. This guy will put out sinusoidally modulated pulse widths, adjusting in real time to how much power is currently drawn. Right next to the DSP is an STM32 clone from GE. That's the first time I hear about that brand. Its job is a bit more diverse. It reads and writes the display module, interfaces with the real-time clock next to it, talks RS485 and CAN bus to all the BMSs and extension battery packs via their respective transceiver. And on top of all that, it's also in charge of public relations. It's connected to the Bluetooth module, therefore it's the contact person for the smartphone apps. Judging by where the bottom ribbon cable goes, I'd say that one is mostly dedicated to the MPPT charger circuitry. I can't quite follow the traces, but if I had to guess, I'd say that that's another job for the DSP. Sounds like a not so complicated task, but remember, this 900 watt MPPT circuit is buck boost capable. I was briefly puzzled and not at all sure if this really was the MPPT part of the circuit. Google's AR translation also wasn't of much help. Pick up air? Air connection? Steam short? Until I had the glorious idea of OCRing and googling those exact Chinese characters. Ah, yes, that is exactly the kind of ruggedized circular connector that the AC200MAX uses as a solar and DC input. So that's confirmed. Normally I really enjoy scouting out high power boards like this, because you can just follow the thickness to figure out exactly what's going on where. The battery power comes in through two parallel XT90 connectors and is stored first of all in a large bank of electrolytic caps as was foretold. From there I think we've got two simple high-power DC to DC converters working in parallel. I'm just guessing here, but that was probably easier to fit inside of this wind tunnel type of assembly. And two transformers were likely cheaper than one supermassive 3 kilowatt chonker would have been. These DC to DC transformers are chosen specifically for the region that the inverter is meant to be operated in. For Europe you want approximately 325 volt DC to be deposited in this next bank of capacitors after rectification. A last set of power transistors can carve the final 230 volt AC output out of that, and after some filtering and smoothing it's ready to enjoy. Deep down in there we can kinda see a very similar battery module peeking out, just like the one we found in the extension pack, so I'm not going to dig this one up. This video is way too long as it is, but I enjoyed making it. Overall, the AC200MAX feels like a very sophisticated and mature product, and that kinda took me by surprise, to be honest. Power stations like these are getting very popular at the moment, and so naturally there is a lot of low quality being released to the market to make a quick buck while the hype lasts. I hope I've given you a good impression of what to expect from a high quality unit. And that's about it. Only the one most important question I've kept for last. Can it charge itself? Thank you for watching and see you soon on the Reps Battery channel.